All right, so we are now doing question 2.2, explain the economic optimum of the supplier in perfect competition and monopoly. Of course, the first thing that we should do is to define what we call by perfectly competitive market and monopoly market, which is something that I have already done in question 2.1. So I'm not going to repeat that. Just please watch the recording of question 2.1 where I define those two market structures. And in this video, I'm going to focus on the graphical representation of the equilibrium. I'll start with perfect competition, the two side-by-side diagrams, and then I'll do monopoly. But before, perhaps something we can do is to explain what we mean by economic optimum for the firm. The firm, usually the assumption that we make in economics is that firms, they make decisions in order to maximize their profit. Profit is the difference between total revenue and total cost. And the rule to maximize profit, which we call the optimum output rule, is to produce a level of output where the marginal cost, the cost of producing one more unit, is equal to the marginal revenue, the money we receive when selling another unit, which makes sense because if the marginal revenue was higher than the marginal cost, we should produce more. It would cost us less to produce one more unit than what we would receive. So yeah, we should do that. And on the other hand, if the marginal cost were higher than the marginal revenue, we should produce less. So it's only when the two are equal that the firm maximizes the profit. So let's start with perfect competition. So this board is a bit small, but I'll try to make it as clear as possible. Okay. On the left-hand side, I'm going to graph the market. So of course we have the price and the quantity. The quantity is, let's say, measured in millions of units. Just to emphasize that, well, it's the overall market. It's big. So it's the market. You could say that this is the market for any agricultural commodity, let's say the market for soybeans. And this is the price, let's say in dollars. Right? Of course, in this market, you have the market supply. And you have the market demand that determine the equilibrium price, P1, and the equilibrium quantity, Q1. That's it. Pretty simple. Now, what we have to do is to see what happens for one individual cell inside this market that operates inside the market. So we still have price quantity. If you want to label it cost revenue, you can also do that. Maybe that's better, actually. Let's just put cost and revenue. Because we're going to graph the cost curves and the revenue curves. So costs and revenue. And this is an individual cell. One among all the cells in the market. The quantity here could be in, I'll just write K for thousands. Why do we do that? Just to emphasize that, well, of course, the unit on the x-axis is not the same because this firm is much smaller than the overall market. Remember, atomistic supply. What happens is that, of course, these two graphs are interrelated because this is the market price, P1, and clearly, nobody would, in the market, no buyer, would want to buy from that individual seller for a price that is greater than P1. So the individual demand to this seller would in fact be zero above P1. We're not going to graph it. Just remember that nobody wants to buy soybeans from that seller for a price greater than the market price, of course. And if for some reason, hypothetically, if for some reason this particular seller decided to sell soybeans for less than the market price, for less than P1, then the entire market would, all buyers basically in the market would want to buy soybeans from that particular seller. So in that case, this firm would attract the entire demand, but this firm does not have an incentive to do so because it can sell as much as it wants at P1. So usually the way we represent this idea is that we just graph an individual demand that is horizontal, just to emphasize that basically above P1, there is no demand, and below P1, you would have an infinite demand. Okay, so it just changes from 0 to something very large at P1. Okay, I'm not gonna enter too much into the details. So what does that show? This is the individual demand, so DI for individual, which also shows the average revenue for the firm, which is basically how much we receive every time we sell one unit. In that case, of course, it's the market price, which is the same. In this case, we'll see it's different in the monopoly, which is the same as the marginal revenue, which is the increase or the change in total revenue when we produce one more unit. Of course, if I produce one more unit, my total revenue will increase by an amount equal to the market price, P1. Okay, so we have revenue curves, average revenue, marginal revenue. Remember that to maximize profit, the rule is MC equals MR. We have MR, but we don't have MC. Well, let's add it, let's graph it. So MC usually is represented as a swoosh shape like that. That's the marginal cost. I'm not going to explain why. And something that we know from production theory is that the marginal cost is going to cut the average total cost in its minimum. The average total cost curve has a U shape. In the long run, that's because you initially have economies of scales. So the ATC goes down, and then at larger levels of output, these economies of scale, so it eventually goes up. And I'm going to, in this case, I'm going to put, to make sure that my ATC curve cuts the individual demand curve, okay? If I, just for the sake of example, if I did something like that, which is a possibility, but in this case, this firm would make a negative profit, subnormal profit. I'd rather use an example, it's more common and probably easier to show an example where the firm, when each individual firm in perfect competition makes abnormal profit in the short run, and we'll see later how in the long run this abnormal profit will be eliminated. So let's just, I'll try to do it as clearly as I can. All right. So that's my ATC. It's not going to be amazing, but that's going to work. Right, so we have MC and we have MR. We know that the economic optimum or the profit maximizing level of output is what MC is equal to MR, which is right here. Okay, let's just call that Q1 or lowercase q, because Q1 is already there. Q1. This is the quantity of output that maximizes the firm's profit. And in fact, the profit, we could identify it. I don't know if I should do it because my diagram is a bit small, but basically, remember that profit is total revenue minus total cost, okay? Which is the same as average revenue times quantity minus average total cost times quantity. And the average revenue is the price. So that's just Q times P minus ATC. So the reason I've done that is because this is how we're going to identify it graphically. Q, which is here, how much we produce, times P, which is there in the price, P1 minus ATC. So the only thing that we are missing is the average total cost at Q1. So I find it by going up from Q1 until I meet the ATC. And again, it's not amazing, I apologize. And this area, I'm not going to shade it because otherwise we won't see anything when I show the long-term adjustment. But basically this rectangle is the abnormal profit. You see the price is greater than the average cost at Q1, which indicates abnormal or supernormal economic profit. This is a short-run equilibrium. How do I know that? Because in the long run, we know that all firms in perfect competition make zero economic profit. They make normal profit. And I'll explain why this is the case. So if you see a situation where a firm that operates in perfect competition either makes like a positive economic profit or a negative economic profit or a gain or a loss, that tells you that we are in the short run. Basically, there is a single difference between the short run and the long run in perfect competition. In the short run, there is a fixed number of firms in the market. What it means is that basically firms don't have the time to enter or exit the market. In the long run, however, firms have sufficient time. This is really how you should understand it. Firms have enough time to enter or exit the market. And remember that in perfect competition, there are no barriers to entry or exit. So they are free to enter or exit. So that's the short-term equilibrium. What's going to happen in the long run is that there will be firms outside the market that will be attracted by the existence of this abnormal profit. Oh, wait, look at that. In this market, we can make a lot of money, a very high profit, more than normal. So they want to be part of it. They want to enter the market. As you have more firms who enter the market supply will increase, will shift to the right. And as you can imagine, as the market supply is going to shift to the right, the equilibrium market price is going to go down. Okay? And as the equilibrium market price goes down, the abnormal profit is gradually going to be eliminated. Basically, each individual firm that is in the market is going to make an abnormal profit that is going to become smaller and smaller. And you have more and more firms who enter the market. And clearly, this entry process is going to stop when all of this abnormal profit is gone, has disappeared, which happens when the price, the market price, is equal to the minimum of the average total cost. So if you want to graph it properly, I'm going to use a different color. The first thing that you should do, you should really start with the right-hand side diagram rather than this one. If you if you show an increase in supply, it might not be, the new equilibrium price might not be exactly at the right level. We know that the new price must be at the minimum of the average total cost of a bed. So it's DI prime, which is, again, the new average revenue and the new marginal revenue. So that's where we must be. Let's call it P2. Price has decreased. So that tells me where I should be, the new equilibrium price. So firms enter the market, and we have, of course, a new quantity that is high. So firms enter the market, they are attracted by this abnormal profit. This decreases the equilibrium price, and this entry process stops when the price reaches the minimum of the average total cost. Now, what is the new economic optimum for each individual firm? Well, again, it's always the same. MC is equal to MR. MC has not changed. It's still there. However, MR is now this red horizontal line. So the new economic optimum is there. So you see that each individual firm produces less, which is quite interesting, right? Because in the market, overall, we produce more, but each individual firm produces less. Well, that's simply because we have more firms than before. And at that new economic optimum, at Q2P2, you see that the firm, I'll just add an arrow, each individual seller make a profit that is equal to 0, which we call normal profit. How do I know that? Well, simply because at Q2, the price, P2, is exactly equal to the average total cost. And you see that if the price is equal to the average total cost, then the profit is going to be equal to 0. That's a long-term or long-run equilibrium, and that's always the case. We could have done the exact same thing. I'm not going to do it because this would be highly redundant, but we could have done exactly the same thing, assuming that each individual firm is making a loss in the short term. So then certain firms would exit the market, would leave the market. There are no barriers to exit, so they can. So the supply would decrease, would shift to the left. The equilibrium price would go up, and this will lead to a new equilibrium where firms no longer make a loss. The price will go up until it reaches the minimum of the average total cost. And again, normal profit would be achieved by all firms that have remained in the market. Okay, so this is the short-term, long-term, or short-run, long-run equilibrium in perfect competition. Now, how does it work in a monopoly? Well, in fact, this is much easier. Side-by-side diagram that I just did, where I show the short-term, short-run, and long-run equilibrium is a bit tricky. Well, in a monopoly, well, there is no difference between the market and the individual seller because there is a single seller that faces the entire market demand, right? And again, I have already defined what is a monopoly in the previous video, so you can simply refer to the content of that video. Quantity, and again, we can just write cost revenue. It's okay if you write price, but cost revenue is a bit more general. So this monopolist is facing the entire market demand. So D is the market demand. Of course, it's downward sloping. And it measures the average revenue, okay? Because basically it tells you for any given quantity, okay, oh, I want to sell this quantity. The demand tells you the price, or gives you the price at which you can sell this quantity. And of course, you can see that the more you want to sell, the lower the price that you have to charge, okay? Clearly, if you want to attract more buyers, there is no other ways than decreasing the price. Remember, the average revenue is the price, basically. So you see that the more you want to produce, the lower the price that you have to charge. And therefore, this price is given by the demand curve. Now, what is quite interesting is to understand that the marginal revenue in that case is going to be different than the average revenue. I'm not going to explain that in too much details, but basically the reason is that unlike what we had in perfect competition where I could sell as many units as I wanted at the market price, so I did not need to reduce the price to sell more units. In a monopoly, the only way in which a firm, the monopolist, can sell more output is by cutting the price. And the consequence is that the marginal revenue is going to be less than the average revenue, less than the price. Graphically speaking, the two lines will have the same vertical intercept. They will both be downward sloping. but MR is going to be twice steeper than AR. So we have the revenue curves, and again, just like in perfect competition, profit is maximized where MC is equal to MR. I have MR, I don't have MC. Let's do it. MC, you just do this swoosh shape. That's the marginal cost of production. I have MC, I have MR, so I could already identify the optimum, but I also want to graph to add the average total cost curve so that we can show the profit. And again, just like before, but I'll show you different cases here. I'll initially assume that the ATC, how am I going to do that? Let's say that. Okay, not amazing, but that's going to work. Yeah. Again, U-shape for, don't forget to label your curves, U-shape for your average total cost curve and make sure the marginal cost cuts ATC in its middle. So, economic optimum, MC is equal to MR. MC, MR, boom, right here. That's Q1, why not? Now, careful, there is a very common mistake, is to say, okay, I have the quantity, this is the price. No, please do not make that mistake. I can tell you the examiner waits for you to make that mistake. Think about it. It would not make sense to charge the price over there. If you charge this price there, the one I just erased, the quantity demanded would be much larger than what we intend to sell. We want to sell Q1. We don't want to sell more than Q1, right? So we have to charge the higher price that consumers are willing to pay for this quantity, okay? And this price is given by the demand curve. So we start from Q1 and we go up until we meet the demand curve, and you have the equilibrium price. You see that at P1, consumers want to buy Q1. This is given by the demand curve, and that's precisely the level of output that maximizes our profit. So P1, Q1 is the economic optimum. Now, what we want to do is to find the profit. Is this monopolist making a supernormal profit, abnormal profit, or a normal profit, or subnormal profit? And again, we can simply remember that profit, usually I use the letter capital pi for profit, is just the quantity times the price minus the average total cost. Okay, so the quantity is there, the price P1 is there, I just need the average total cost. How do I find it? I just start from Q1, I go up until I meet this average total cost, and that's ATC1. Q times P minus ATC, that's the profit. This one I can shade it because there is no long run adjustment. Why? Because there are very high barriers to entry. So even in the long run, nobody can enter, so it doesn't change anything. This red shaded area is the abnormal profit, positive or supernormal economic profit. Okay. Something else, it's perhaps a bit beyond the scope of the syllabus, but you could also identify what we call the dead weight loss or the welfare loss that would be caused by this monopolies. And in this case, you simply have, it's quite simple. I'll try to explain it in very simple terms. The thing that you must understand is that basically, if we imagine that the government is tired of having this very powerful fund and decides to break it down into many small companies, so it would effectively move from a monopoly to a perfect competition. And the supply curve, under certain assumptions, but let's keep it simple, the new supply curve in this new perfectly competitive market would be the marginal cost. Okay, it would be a section of the marginal cost, but this would be the supply. And so the equilibrium would be where supply is equal to demand, over there. Okay, so you see that if we moved from, if we were, hypothetically, if this market were perfectly competitive, we would produce Q2 rather than Q1, and the price would be P2 rather than P1. So we see that the price in perfect competition will be lower and the quantity would be higher. And these different optima, this different equilibrium between the monopoly and perfect competition mean that overall the overall welfare that is generated by the market is less in a monopoly than in perfect competition. We haven't really talked about consumer surplus and producer surplus, so that's quite tough to explain in greater detail. But basically, you see that you have a triangle over there. It's almost a triangle, looks like a triangle at least, which is defined by 3 points: the perfectly competitive equilibrium, the MC-MR equilibrium, and the P1-Q1 equilibrium. And this triangle is what we call a dead weight loss. And that's basically a loss in the welfare that is generated by the market. The fact that this single firm has so much market power leads to a situation where the market does not generate the largest possible surplus or welfare. And this is precisely what we call a market failure. The market fails to achieve, to generate the largest possible level of welfare. But again, it's a bit beyond the scope of the syllabus. It's enough if you identify the equilibrium of the profit. Just for the sake of illustration, I want to show you another situation where instead of making abnormal profit, the monopolist would make subnormal profit or loss, which is exactly the same thing. I'll just show you the only thing that changes. It all has to do with the ATC curve. The price, again, it's cost revenue, CR for cost revenue. So we still have the demand curve, the market demand curve, which is the monopolist's average revenue. We have the marginal revenue, the marginal cost, same as before. The only thing that's going to change now is that instead of graphing an ATC curve that cuts the demand curve, I'm going to graph an ATC curve that is above the demand curve. You'll see that the difference is quite important. The optimum is still where MC is equal to MR. This doesn't change. Q1. The price, of course, we still need to go up until we meet the demand curve, P1. But now, to calculate the profit, I need to find out what is the ATC, the average total cost at Q1. So again, I go up until I meet the ATC curve. You see that it's quite high. So now the profit is the price minus the ATC, but you see that the average cost is greater than the price. So this gap is in fact a per unit loss. Okay, the gap between P1 and ATC1 is how much money is lost by the firm every time it produces a unit. And so this rectangle, it's not a profit, which it's a negative profit, it's a loss. That's the subnormal profit. Oops. That is the subnormal profit that the monopolist receives. You could also show the deadweight loss if you're interested. Again, if we were in perfect competition, the supply curve would be the marginal cost, supply demand, boom, this is where we would be. So again, we would have a larger quantity and we would have a lower price, and the deadweight loss would be represented by this triangle over there, the loss in welfare caused by the market power of the monopolist. Okay, I think that's about it.